Well, hey, you are the survivors, right? This is the last full-length session of the last day of the conference. So the fact that you're here shows that you are mighty. You are powerful. And I want to maximize your investment here. I'm going to give it to you for the full time. Hopefully not much more than that. But I want to make sure you get your worth out of this. I do have to start off with a little bit of housekeeping. I always take a selfie with the crowd to prove to my boss that I am actually working at some point on these trips. So if you would, just everyone smile and say, Spring. OK, now this side too. Reactive. All right, OK. So with my superb photography skills, we may not get any, but we tried, right? So welcome to this afternoon session on full stack reactive Kotlin. I like Kotlin, I like Java. We're going to mix it up. We're going to give you two for the price of one here. Has anybody used Kotlin here? Any fans? The expressive elegance, the conciseness. So I think it actually helps convey what you want to convey without a lot of extra static. So I think it's very useful for this. I also tend to narrate extensively while I code. So if you're not familiar with Kotlin, you're going to find, one, it's a fairly gentle on-ramp from Java, but you'll also find that I do a lot of explanation, so I don't think it's going to, you're not going to feel very uncomfortable at all, frankly. I don't think. I've actually done this talk both ways, and I kind of debated, and I threw it out at the audience, and they're like, no, we like that kind of introduction to Kotlin. And I'm also going to mix in some Java as well as we go. Probably do the Java client, just to, again, free for all here. So we're going to be talking about Spring Framework 5, Spring Boot 2, and Project Reactor. My name is Mark Heckler. I actually work on the Spring team with Pivotal, for Pivotal, but I am a professional problem solver. Aren't we all, right? I'm also a Spring developer advocate, again, for Pivotal. I blog, not as often as I would like, but I'm hoping to improve this year, maybe, at thehecklers.com, occasionally at Spring.io. I am on email. If you would like to reach out to me, by all means, please do so. The best way, better than email, though, is Twitter. I live on Twitter. And that's probably the fastest, easiest, best way to reach me, no matter where I am at the time. And I do semi-often check my email, but it's just a little more lag time. So we don't have enough time to cover everything exhaustively, but what I want to do is give a really solid introduction to things, get you started on the fast track, and then to start the conversation. So let's carry on the conversation. Ping me on Twitter or email, and we'll go with that. So who am I? I've co-authored a couple of books. I've contributed content and code to several other books, some of which even acknowledged me. That's always nice. The other ones, well, don't buy those. Anyway, I am a frequent event speaker. Have been to JFocus a handful of times and love it. So hopefully they'll let us all come back again soon. In spite of them knowing me, they do let me come back, so that's good. I am an architect and developer, and as you might guess from the next bullet point where most of my expertise has been won, it's in the realm of Java. I was inducted into the Java Champions a few years ago for ongoing contributions to the greater Java community. Doesn't stop me from experimenting with Kotlin and other things. It's not a monogamous relationship, right? And it does tend to improve your chops when you learn things that are a little bit outside your normal swim lane. So what's this stuff about reactive programming? I love this quote by Rossen Stoyanchev, one of our Project Reactor team members at Pivotal. He said, in a nutshell, reactive programming is about non-blocking, event-driven applications that scale with a small number of threads, with backpressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now, that packs a lot of meaning into one sentence, which is why I like it. But let's unpack a little bit, shall we? The mechanism that Java has traditionally used for scaling has been very simple to understand. You typically, with each additional connection, you have an additional thread. So over time, what you wind up doing is having a lot of threads, which at any given point in time may be doing what? Nothing. They're blocking. So it's very easy to reason about and very easy to understand, but it's not always the most efficient, right? Not always the most resource efficient. So what we were looking at is a better way to handle those interactions and to scale more dramatically. We didn't want to scale with one thread. Other environments have done that and have proven that you can do amazing things with it, but you can also, it's rather prone to disruption, right? So scaling with a small number of threads gives you a lot of power, a lot of control, while still maximizing your resource utilization. So few resources, big utilization. I do want to say that sometimes people ask me what kind of a performance bump will they get if they go to a reactive programming model. Probably the wrong question to ask, Because when you're talking about a single connection, let's just go to the absolute extreme. You have a single connection. You can't get better performance than a blocking connection, right? A blocking interaction. Because you're saying, give me a response, and I'm waiting right here ready. As soon as you get it, got it. You can't beat that, right? So when you insert an event loop, it gives you, again, that wicked scalability. So you have the ability to service a vast number of connections and requests with a small number of resources. But if you have one or two connections, right, one or two requests coming in at any given point in time, you may see a slight performance degradation. But what you see is a very flat performance profile in a reactive programming model. So your scale doesn't hit this hockey stick. It typically just stays fairly flat for a much, much, much longer time. It's crazy. Backpressure is a key ingredient. Sometimes you have folks who say, well, what about coroutines? What about Project Loom? Things like that. Those are all great, but they don't do anything about flow control, right? So a reactive model where you have publishers and subscribers, which I get into briefly in a moment, adds backpressure. Sometimes you also hear folks talking about asynchronous programming, which in and of itself has been around a long time, right? It's a little messy at times. You've probably heard the term callback hell. That was invented for a reason, and probably an optimist coined that term. But you have a bunch of nested callbacks, not always, again, the best to decipher and untangle. So we want a little more declarative approach. But also, in terms of asynchronous programming, there's nothing inherently in asynchronous programming that allows a slower subscriber, a slower consumer, to say, look, you're killing me here. You're giving me 1,000 values per second, and I can only handle 10. So what happens? Your slower consumer is just inundated and overwhelmed. Backpressure is a key ingredient to reactive programming. It allows a slower subscriber to say, give me 10, give me 20, give me 50 if I can handle that. And when I'm ready, I'll let you know that I'm ready for more. It doesn't change the fact that you have a very fast a very fast service that's producing a large number of values, but it shifts the controls to the service, to the cloud, to the server that you have control over versus some remote client that you may not, right? So that's a very powerful concept. So very quickly, this is all based on reactive streams. The Reactive Streams initiative, again, saw that a lot of the problem with scaling is in the interactions, the streams, if you will. So they determined that in many ways that we could kind of pattern this after the typical imperative approach, and I'll get into that a bit as well, but we could have constructs like a publisher, which is the thing that produces values of type T. These are 4 interfaces defined in the Reactive Streams specification, right? They're just interfaces, so you have to either create an implementation or use an implementation. And the devil's in the details, but there are numerous implementations you can choose from, well-tested and proven. But they all adhere to the spec, and they're all demonstrably adherent to the spec because there is a TCK associated with it. So they can use the technology compatibility kit to verify where they may fall short and fix it, which is good. You have a large amount of cooperation between various titans in the industry. So Twitter, Kazing, Red Hat, Pivotal, Oracle even came on board at Java 9 with Java Util Concurrent Flow, which implements, or which provides, I should say, the interfaces like publisher and subscriber and things like that. I'm kind of digressing here. You have a publisher of, let's say, values of type T. You have a subscriber that subscribes to those values of type T. The contract between the two is a subscription. So that's a contract entered into between subscriber and publisher. And then you have a processor interface, which actually incorporates both the subscriber and the publisher interface, so it can receive values, manipulate them, and pass them on. Very simple. Deceptively simple, right? But the good news is there are numerous implementations, one of which is Project Reactor, which Pivotal shepherds. You also may have heard of Akka Streams and RxJava. Others don't come to mind, but the idea is that you have various different implementations that provide a lot of the same capabilities, but a different way of doing it, right? But they're interoperable. When things are not interoperable and they do the same things, who gets caught in the middle? We do. We're the ones writing the glue code, right? We're the ones that our boss comes and says, hey, this system is using that, and that system is using library X, and you've got to get these things talking and communicating and passing stuff back and forth reliably by Friday. And it's Thursday. And that's never good, right? So you want something that will be adherent to a particular standard, and obviously these are. We also have a large degree of cooperation, which is good. I like to point out that one of our strong committers for Project Reactor is David Carnock, the lead of RxJava 2. Stefan Maldini, who leads our project, actually commits to RxJava. So Akka Streams folks, we all get along, which is good, but we have a little different perspective on how we want to implement this. Project Reactor forms the underpinning for the reactive bits within Spring Framework 5 Spring Boot 2. Don't have to use Spring to use it. I don't know why you wouldn't want to, but you don't have to. I know folks who are using it on Android. So you can do that. But the idea is, of course, that you have your number of choices. So let's code. I like to jump into the code as quickly as I can because there's just so much material I want to cover. And I think we have an understanding of where we're coming from now. So let's do this. Is anyone familiar with this site? Actually, I'm just going to pop up a new one. So start. Oh, that's nice. OK, so that's a little cleaner. So this is the Spring Initializer. This is your starting point for creating Spring Boot-based microservices on the web. You don't have to use this. You can create them all by hand. You can curl it. You can use it from your IDE. But I like to go to the website because it's kind of a nice jumping off point. It doesn't write code for you. It generates your project shell, based on dependencies you choose. And of course, Spring Boot has auto-config. It simplifies your dependency management and your deployment, right, with a fat jar. But this allows you to get started very quickly by choosing a few defaults, and you're off and running. So I'm going to do that. You do have a lot of options here. So even with an opinionated approach where it kind of streamlines it and you can jump in fast, you do have some options to choose from. If you are a Maven developer, you can choose to generate a Maven project. If you're a hipster, you can choose to generate a Gradle project. I'm feeling the hipster today, right? I've got the hoodie. I actually did shave off the beard before I came, but I'm still going to go with Gradle for this one. I used Maven earlier today, so I'm trying to not play favorites here. So I'm gonna again start off with a Kotlin project, and we'll come back and wrap up with a Java client just to keep things again fairly even. I'm going to change this to the Hecklers because it doesn't work if I leave it as example. Kidding. OK, boy, this is a tough crowd. You all are still out there, right? I mean, it's hard to see with the lights, but OK, good. They always tell you to do what you love, right? That's life advice. Do what you love. I love this. I love to write code, and I love to talk. So this is kind of the ideal. But what else? You know what else I love? I love coffee. So in fact, I even brought this in case I start feeling a little down. In fact, hold on. Oh, yeah, now we can go. OK, so we're going to create a coffee service. This is, I think, an ideal domain to explore, right? Because this is something. Does anybody here not like coffee? Really? OK, please let them leave now. Kidding. All right, it's all right. I don't understand you, but it's all right. OK, so I'm going to choose my dependencies just off the list here. You can also break this out to the full version and choose them off the menu, the checkboxes. I find that a bit more tedious, so I'm just going to search here. So I'm going to choose my reactive web dependency. That gets me my reactive bits, Project Reactor. It brings in Netty by default for my reactive engine. If you've used Spring MVC, any Spring MVC developers out here, you're probably familiar with Tomcat being the default for Spring Boot MVC projects, Spring MVC projects in Spring Boot. But you could swap that out, right? You can use things like Undertow and Jetty. Well, guess what? You can here as well. You don't have to use Netty for your reactive engine. Any Servlet 3.1 compatible engine, so Tomcat 8, I believe, Undertow, Jetty. But Netty is well tested, well proven, and it's the default, so we're going to stay with that. I'm also going to use reactive Mongo for my database. You have to store in something. Mongo is a great choice. Spring Data supports 4 different databases with reactive drivers: Mongo, Couchbase, Cassandra, and Redis. And we also have an R2DBC project. People always ask, hey, is there anything for relational databases? This is early stages. It's r2dbc.io, r2dbc.io. It's something that some of our engineers are heading, but we've got wide industry contributions. Postgres, MySQL, Microsoft folks contributing things, and that's coming on very quickly. So if you want to get involved, that's a pretty awesome project. I'm going to stick with Mongo today just to keep things simple. I'm also going to bring in embedded Mongo for a couple reasons. It's just so much fun, and it keeps things clean. And when I say fun, I mean it. I'll show you that here shortly. I'm going to save down the project, and let's go to my desktop, and we'll unzip that. And I'm going to open this in my favorite IDE, NetBeans. I'm just kidding. I like NetBeans. I like to pick on NetBeans because it's cool. I used to work for Oracle 100 years ago. And NetBeans is an awesome IDE as, I started to say as is Eclipse, but I can't lie to you guys. I mean, really, I'm kidding. Obviously, Eclipse lovers. Please tell me nobody uses Emacs. OK, we're done here. All right. So I'm going to blow this up, and there we go. So I've got my project loaded into my IDE. I'm just going to go and take a look at my build.gradle file. I do need to change something, because for some reason, the initializer is still loading 1.2.7.1 of Kotlin. I want to use 1.3.20, which is the current. I need to let somebody know, and we need to get that fixed. So it's asking me if I want to run the migrations. Well, I've got so much code out there, I'm not sure it'll work, but let's find out. Oh, look, no suspicious code found. Whew. OK, so the other thing that I want to start off with that I need to do is I've got the embedded MongoDB instance that's going to start up just for tests, and I want to actually change that to implementation and shift that up. One of the reasons I love using the embedded MongoDB database, because just frankly of the name. It was created by a German fellow, and he named it inexplicably Flapdoodle. We all know Germans are well known for their sense of humor, right? With a last name like Heckler, you can probably imagine where I get my stellar sense of humor. But it's an awesome product, and it works really well for just the local instances. So that's what I'm going to use, in addition to having a fun name. You can't even say it without laughing, right? Flapdoodle. It just sounds fun. All right, so let's go to our main application class, and let's get started coding here. So go away. There we go. So we're going to start with our domain. Kind of makes sense, right? You have to start somewhere. I'm going to create a class called coffee. Clever, right? It's coffee service. So with Kotlin, with Java, you're probably used to rather large domain classes where you have a lot of boilerplate. With Kotlin, you can eliminate a lot of that. And there are tools like Lombok you can use with Java, but Kotlin incorporates this stuff into the language, which is pretty sweet. So with Java, you typically have a number of constructors for a class, right, with varying arguments, varying numbers of parameters. And that's fine. That gives you a lot of flexibility. With Kotlin, you don't really need that very often. You can have primary and secondary constructors, but in most cases, you have options enough that you can define a single primary constructor with some different options that allow you to have a lot of flexibility, which I will show you. You don't have to, and I guess I should also say, in Kotlin, you don't have necessarily the construct of memory variables and getters and setters, accessors and mutators if you want to feel fancy, but you have the concept of properties, which are public by default. So you don't have to expose getters and setters. You can expose one or the other, but you can, and by default, you do. They're a property, because most of the time when we have a memvar, what do? We have a getter and setter. So almost instantaneously, you've chopped down your class. When you have a single constructor, a single primary constructor, you can even just define it up here in the header like this and put your parameters with your properties in there. And in fact, if you only have the primary constructor, you can just do that and shortcut it even further, which is pretty sweet. So I'm going to start off by saying, look, and of course, you can use all the same annotations. So I have my ID field, and this will be a val. You can define variables, which are mutable, or values, which aren't. They're like final variables in Java, where there's assignable ones. And I'm going to expect my coffee to have an ID, and it'll be of type string. I'm also going to have a property that is a value, val, for name. Each coffee should have a name, right? And that will also be a string. Sting, yes. I type fast, which means I also typo fast. So if the first row will keep an eye on me before I hit build, thanks. So we have a coffee class, and that's OK. That gets us our getters and setters right off the bat, and we obviously have a constructor. But we also want to provide some things like a default value. So if we don't provide a name in a constructor, let's just say this coffee or any coffee will be called any old Joe, which sounds kind of sad, right? Hopefully we'll never have this. But we also know that with Spring Data and MongoDB, we're going to have the ability to have Mongo assign our ID for us. So we don't want to necessarily have to pass in an ID. And this is a value, right? It's assignable once. But we want to say it's OK to have that be a null value. Kotlin has null safety. So if you define a variable or a value as a string, guess what? It's always a string. It cannot be a null. It is, I won't say impossible. Nothing's ever impossible if sufficiently motivated. But it's generally impossible to have a null value when you define something as, for instance, a string. How do you say it's OK to make it nullable? Well, you change this. You simply add one character, just one little punctuation mark, to take this from being a string to a string. It's very subtle. I'll do that again. So with just the string defined, it's a string. But when you add the question mark, it's like, string? Is it a string? Is it not a string? So we're going to say that it's OK to have a null value here. We know Mongo's going to assign it. It's fine. But by adding the question mark, we say it's OK to be nullable. Now, that gets us a lot, right? That gets us our getters, setters, our constructor. But what happens if we want, and we do, to have our equals hash code toString, a copy function, things like that, a component in functions to where we can access our various components? Kotlin has a concept of a data class. So if you're used to Lombok with that data, guess what? You've got it, and it's built into the language. So this is your whole domain class. How much easier is that to debug? How much clearer is that? That's so nice, right? So that's OK. That's a sufficiently good start, but it's not enough, because when we have a coffee service, we can envision this being used by baristas around the world. Numerous locations in every city across the planet, around the planet. It is round, right? OK, good. So we want to track coffee orders, because we want operational insight. If there's a coffee that's being ordered 1,000 times per minute, chances are we want to have complementary coffees in our catalog so we can sell more, right? That's a good thing. If a coffee's only being ordered once a year, we want to drop that turkey because it's costing us money. So we need access to these orders. So I'm going to create another data class called coffee order. Couldn't see that one coming, right? And we're going to have a constructor here with val coffee ID, and that's a string type, of course, and a val of when ordered, so we can see what the timestamp was for an order, and that'll be an instant. We're also going to create a repository here by extending an interface defined in Spring Data. This is part of Spring Boot's auto-configuration. If you extend an interface from Spring Data in your application, and you have a database driver in your class path, guess what? Spring Boot says you want to talk to a database. That's what some folks call magic. It's really science and technology. It's OK. So we're going to define a coffee repository so we can interact with our data store. And Kotlin, you don't have to type the messy extends. It seems so long, right? That's 6 whole characters. Just a colon will do. And we're going to extend our reactive CRUD repository defined in Spring Data. We're going to persist objects of type coffee with IDs of a type string, and that gets us started. Now, what we want to do now is have some data so we can see what's going on. So I'm going to create a component, and we'll call this class data loader. I'm great with names, right? I'm also going to inject, via my constructor, an instance of my coffee repo bean, right? And that'll allow me to interact with my repository. So I'm also going to make this a private val repo, right? So this will be the reason I do that is if I do this, it's now a property within my data loader class that is exposed publicly, which is fine, but it's already a bean that is accessible publicly throughout my application. So I don't need to expose it from within my data loader, so I'm just going to make this private, right? And then let's get started. So what is our basic internal service? Well, actually, I'm getting ahead of myself. I got to load some data. All right, so let's do a post construct method. So we'll do a private function. And I should say, Kotlin doesn't have methods. It has functions. And the keyword for function is fun, which leads us to the expression, everything is fun in Kotlin, right? I know it's corny, but I did not make that up. Okay, I'm just repeating it. So we're going to create a function, which lets me show you something else that's kind of cool. We're going to call this load, right? And in Java, you do this, which is fine. But if you have a single expression that makes up the bulk, the content of your function, you can do a simple assignment. And that's exactly what I'm going to do here. So rather than have the brackets and the return statement, we just do a direct assignment. And everything evaluates as an expression and returns, and it's just happy as can be. So what do we want to do? Let's populate our data store here. So I'm going to create a Flux. I should back up. Remember I showed you the publisher interface in the reactive streams? Project Reactor actually specializes that. In Java, if you're returning something from a method, for instance, you can return an object of type T. Or you may return an iterable of type T, so some form of collection, right? So you can get one or a bunch of somethings. This kind of makes sense to have this separation as well in a reactive model. So we say that, hey, look, if you're going to return 0 or 1 values, that's a mono. You can expect a value eventually. Maybe very quickly. Maybe it's sporadic. but it'll eventually come. If you have a publisher that can return a collection of values, maybe if we call it a reactive list, it's a little misleading, but we'll go with that for simplicity. If it has several values, 10, 20, indefinite numbers of values, that is a flux. And some operations apply equally well to both, some only to one or the other. So again, it makes sense to specialize. So I'm going to create a flux of just these values. And here's the audience interaction part. Very important. You've heard garbage in, garbage out, right? So we need some prime coffee names. This is important. If we get bad coffee, we get bad examples, bad demos, bad outcomes. So who has a favorite coffee? What is it? Kimball? Cannonball. Okay, spell it for me. What is it? Oh, Kimbo. Oh, gosh. Okay, it makes, now that I see it spelled, it's like, oh, yeah, duh. Okay. Yes, have seen it. Is this your favorite? Okay, I like it. Anybody else? What? Lou? L-U? Okay, spell it out for me. Oh, Blue. Blue Java. That's a thing? That sounds like something I'd be afraid to drink. Oh, I will try it, though. I'll try anything once. Okay, anyone else? Urban. Okay, did you say urban jungle or bourbon jungle? I just want to know. Bourbon? You're serious? Oh, my gosh. Okay, see, my ears heard bourbon, and I was like, nope. And my brain auto-corrected it. So bourbon jungle. This sounds better than Blue Java. I'm sorry. It really does. Okay, anyone else? Going once? No favorites? Okay, I'm going to, oh, yes. Okay, what I heard was Pike Place. I'm going to go with that as the lowest common denominator, okay? All right, so we're going to start there. This is a Flux. This is a publisher we're creating of just these values. Very simple, flux.just, right? This is a factory method, if you will. So then we're going to take that and we're going to map those values. Now, here's another cool thing about Kotlin. If a lambda is the last parameter in a method, set of parameters in a method, you can just eliminate the parens. Oh, sure, of course. It make it hard for me here. So instead of doing this, it seems a little redundant, right? You can do this and just start right in. Now, I can take each one of these names, right, and I can do a coffee. You don't have to have the new keyword. That's superfluous. We know we're creating something. We don't need to have new whatever. So we know we don't have to provide that first value, so we can put null in there, and then we'll just say name, right? But we can do better. Right? This is kind of the Java way brought in, and that's fine, but we can do a little bit better because we have named parameters, right? So we can say coffee, name, spelling counts, name equals name, and that's good, but we can also use the default name for a single parameter in lambdas, which is it. Name equals it. And of course, since we only have that single parameter, we don't even have to put that. Isn't that pretty? Oh, that's so nice. Okay, so we're going to map each one of these names to a new coffee object. So we're going to create that, and then I'm going to flat map that. We're just going to do a repo.save once again using it. Very sweet, short, sweet, and to the point. And with streams, what happens? It's just like in Java 8 streams. Until you have a terminal operation, nothing happens. And that's very important with publishers, because if you have them doing an awful lot of work and nobody's listening, there are no subscribers, you're wasting resources. So what happens is until you have a subscriber, nothing happens. Until that terminal operation happens, nothing occurs. So I'm going to subscribe to that and kick off the party. And then, of course, I'm going to print line it. And we're off and running. So really quickly, I'm going to run that to make sure I haven't typoed and the front row let me down. You didn't let me down, did you? Everybody's going, oh, you let me down. OK, so let's see what we got here. Well, that's not very descriptive, is it? Well, that's interesting. Okay. So I don't, but I mean it's all correct. Oh, interesting. Oh, that's interesting. Okay, so let's see here. Hold on. There we go. No, sorry. There we go. Losing my mind here. I just never have this come up. Hold on. There we go. Oh, that's so wild. Let's see if that improves the situation any. Well, that's marginally better, right? Okay, so things are running. I guess I'm going to have to be the Heckler here today, so that all works. By the way, I should say that I'm the only Heckler allowed in the room. Sorry, I got here first. Yeah. Again, it's that finely tuned German sense of humor. Okay, so we see we have coffees. They've been stored reactively. There's never any blocking that occurs, so we're highly performant, small number of threads. And by the way, that's all handled for you automatically with the scheduler, but you can tune this, you can tweak this if you want, and do it 100% manual. It's just that it's not very productive to do so, so we don't, in general. So now, let me go back to presentation mode. So we're storing our data, but we're not doing anything else. So what I like to do next is create my internal API. Thank you, by the way, for catching that, wherever you were there. So, okay, yeah, thanks. So I'm going to create my internal API. This will be our coffee service class. Again, typos. Wow. Okay, and I'm going to inject my repo. There we go. And let's get started. So what kind of an internal API will we want to use throughout our application and then eventually to expose it externally? So we're going to create a function for get all coffees, because we know we'll want to return all coffees. And we're going to just say repo.findAll. These are some built-in operations to all Spring data repository-supported databases, which are numerous. Any JPA database, Mongo, Couchbase, Cassandra, so on and so forth. So these are very basic functionality operations that are useful across the board. So things like find all, find one, delete all, delete one, get a count of records or documents in your data store. But of course, you can extend that and modify that if you want. We won't need to today, but certainly the capability exists. So what else will we need? We want to get a coffee by its ID. And of course, we will expect an ID to be provided. So we'll do a repo.findById, passing the ID. And we also want to get some of that operational data, right? So we can get the operational insights. So we're going to get coffee orders for a particular coffee ID, right? And here's where we stop, because there's no built-in operation to our repo that can do what we need to do for this. But we can define that. Now, if we had a running production system, we'd probably have an in-memory data grid that's tracking all orders in real time. So far, nobody's using this. I have high hopes. But so far, no baristas have signed up. So if you know one, we'll talk. But for now, we're just going to fake it, right? I'm going to create a Flux based on an interval of 1 second. So duration.of seconds. So 1 per second is going to create a blip once every second to kind of simulate an order coming in. And then what I can do is map that to a new coffee order. But what I also want to do is define what happens on backpressure. So I don't have to in this case. I know I'm writing the code. I'm going to write the consuming code. I know there's going to be a value every second coming through. So I don't have to define this, but it's a good practice to do it. In most cases, well, in this case, since I only care about the visibility of what's happening now, if I'm producing 1,000 values per second and my slow subscriber is only getting 10 of those, that's fine. Just drop the other 990. You may want to buffer them. You may want to set the size of the buffers. You can adjust that and determine what's right for your particular use case, and that's great. You have the option to do that. For today, I'm just going to drop those excess values, because again, it's kind of like a dashboard. If it's not now, I don't care. And then I'm going to take what comes out the other end, so to speak, and I'm going to start typing right, map each of those blips to a new coffee order. So coffee order, and let's see, we have our coffee ID and instant.now, and that's going to give us a timestamp. Now that should work. If only there was some way to test code before you put it into production. If only. I mean, you can't just throw it into production and see who screams, right? See if it works, if it doesn't. But somebody was telling me there is this way that you can build these things called tests. That's what they're called. So we're going to do that really quickly. I'm just going to show you some of the neat ways you can test reactive code, because it does pose a few different problems, right? Imperative code is relatively simple to test for. You issue a request, you get a response, you compare what you expected with what you got. If it matches, everybody's happy. It's generally that way for a publisher as well. But what happens when you have a sporadic publisher? you may get a value for 3 values in 3 seconds, and then it may be a week before you get another value. That's a little tough to write a unit test for, right? So what we want to do is to be able to time travel, to compress time, if you will, because that way we have a little more power to test more extensively our publishers. So we're going to get into that a bit. I'm going to scope this down. I can just do plain old Spring Boot test and load my entire context, application context, but I'm just going to load what I need with Web Flux test. Talking is hard. And that way I can load the particular beans that I need. I want to load my coffee service. So we'll do that. And then let's get started. I'm going to auto-wire that in so I can reference it. And I'm going to make this a later init var because that way it's dynamic. It comes in when I need it. So this will be our service, coffee service. I'm also going to create a mock bean. And let's see, later init var once again. And this will be my repo. Yep. And then I'm going to create a couple of coffees. So private coffee1. Private val coffee1. I get excited and ahead of myself. And we're going to create this as a new coffee. Our ID, we're just going to provide a dummy ID. So 000-test-111. And we will call this name of coffee, tester's choice. Has anybody heard of taster's choice? If you ever come to the States and you see that on a supermarket shelf, run. Do not walk. Run. It's truly terrible instant coffee. I used to have a colleague of mine who would show up in my talks and just stand in the corner and wait till I asked for coffee names, and he'd yell out terrible coffee names. I miss him, but he had to go. He just had to go. Okay, so I'm going to create another coffee. This will be coffee 2, and we'll make this 222, and we'll change this from tester's choice, great puns, right, to failures. Folgers? Anyway, okay, never mind. Again, if you see it, don't get it. So I'm going to, that gets us started off. So now I'm going to create a before, so we can do a fun setup, and we'll just set up a few things. So we're going to do a mockito.when. So when we do a repo call for find all, we want to then return a flux of just these values, coffee1 and coffee2. So let's duplicate that, and we'll change this to a mono. So if we do a find by ID, well, actually, I should do coffee1.id. Now we're getting an underline here, and that's something else because Kotlin has. I just went blank. Oh gosh, it's right there. So Kotlin will help me out. Who here is a Kotlin head? So when you check to see if something is a null value and you've determined that it is not, you don't have to recheck it. Like Java, you're constantly having to recheck. I just lost my terminology. But what you can do is, and that's very handy because once you've established that something is that actually has a value on a nullable, because I've defined the ID as a string, remember? So it could be a null. And what it's telling me here is, I don't know that this ID is not a null. Can you prove it? So what I typically do in cases like this, because you can see I've defined it right above, is I do something very dangerous. Kotlin has the non-null assertion operator, sometimes referred to as the hold my beer operator. I'm just going to do an exclamation point here. So bang bang, and that tells it to don't bother checking this for null. I've got this. Now in this case it's pretty safe. I can see it right there. It's in a test. It's all right. But don't go lettering your code with this. That's a bad idea, generally speaking. But in this case we know it's fine. So I'm going to duplicate this. I'm going to change this to coffee2. So if I do a find by ID coffee2, I'm going to return coffee2, and we're off and running there. So now I'm going to create some tests. The one in particular that I'm concerned with is that one that I'm generating those coffee orders, right? Because the other ones are straight pass-throughs. And of course, we want full test coverage, but in the interest of time, because I have so much I want to show you yet, I'm going to skip right to the problematic one, the one that potentially I've really done something bad on. So I'm going to define this. And another nice thing is we can set up our function names as something a little more readable. So like get orders for... Look at that. Isn't that pretty? I know. You're all going to run right back and create new tests using icons, using emojis. I would not do that. All right. Maybe I would. OK, so we're going to use step verifier with virtual time. That's where we get the time traveling I was talking about. That's where we can compress time. So when we have a potentially sporadic publisher, or even one that produces, let's say, 10 values in 10 seconds, 100 values in 100 seconds, we can compress that down. So I'm going to use with virtual time. I'm going to use my service to get all coffees, right? And then I'm going to await a certain amount of time. Let's say duration of, let's be safe, right? We're time travelers. We can make it an hour. We can make it 10 hours. Let's go crazy. So we're going to wait 10 hours. And actually, since I'm getting all coffees, I do want to scope that down a little bit. So let's take 10 values. This is an example of backpressure. I'm actually specifying just give me 10. That's all I can take. Once I'm ready for more, I will tell you. So this is your slower subscriber telling our publisher to just hand out 10 values. We're going to wait up to 10 hours for this. Again, we're time traveling. This won't take 10 hours, hopefully. And then we're going to expect next count. I'm going to expect 10 coming out the other end and verify complete. And of course, no semicolons. Kotlin doesn't need them. So I'm going to run this test, this beautiful test with a great name. And we're going to see if this works. Hopefully, we'll get a green bar. Oh, what happened? Boy, this is going so well tonight, or today. So let's see what happened here. Count actual 2. Get all coffees. Oh, get all coffees. Actually, I should do a get coffee orders, right, for a particular ID, right? So it helps when you actually do the right thing. Bang, bang. OK, so let's try that. Yeah, if I do get all coffees, and anyway. OK. So this should work. We should get a green test passed. But that means one of two things. Either your code worked or your test didn't. So it's always good to verify that by putting an expected wrong value. We're expecting 11. We're asking for 10. This should fail. Good. OK, it fails. So that's good. So we'll change this back to 10. Go ahead and run this again. Make sure we have a good working, clean working state. And now our tests are successful, and we can move on. So that is good. So let's go back to our main application class. We've developed our internal API. Let's build on that with our external API. We're going to create a REST controller, right? And request mapping. We'll start this off with coffees for our base URL. Class coffee controller. And we're going to inject our, in this case, our service. So we can use our service. So we're kind of building on our internal API, so we're going to do a get mapping based on our coffees endpoint. So we're going to return, let's say just all. We're going to return our service.get all coffees. We also want to return a coffee by its ID, fun by ID. Again, we're going to use a path variable for this, of course, and grab that ID. So we'll just do a service.get coffee by ID for its ID. And then finally, we want that operational insights for a particular coffee. What are the orders that are associated with that? Orders as they come in, live orders. Once again, path variable, we're going to grab the ID. There we go. Equals service.get orders for the ID. ID. There we go. That's almost enough. But our REST controller's typical behavior is to wait till all values come back and then send them back in a single document. We need to leverage something like WebSocket or server sent events. And in this case, of course, since we're providing values in this kind of 1 per second pulse, server sent events works a treat. So I'm going to indicate that we're producing a media type of text event stream value, which is the way of indicating to our REST controller that this should provide a stream of server events. And of course, with Kotlin, I need to add the array of wrapper, and we're off and running. So actually, let me go back and kill this and stop this, and we're going to restart that correctly. So now let's take a look and make sure that we're getting what we want. It looks like we should, so I'm going to use HTTPy 8080/coffees. HTTPy is curl for mortals, right? Curl for humans. So we have that. Let's go ahead and try to grab a particular ID. We're going to use Kimbo, and we'll pull it back. Everything works. Let's see what kind of orders are coming in for Kimbo. So let's do that, and let's stream those. Look, it's all working. Now that's nice, right? If you're coming from a Spring MVC world, this looks very similar to Spring MVC while giving you the full power of a reactive stack. You're returning publishers, and it seems rather native. So your context switching, your friction, if you're switching between imperative and reactive applications at work in the course of a day is very low. Your friction is almost non-existent, which is very productive. There's also a way to do functional reactive routing. I wish I had the time to show it to you, and if we go through the client and there's still time, I will. But for now, I'll just point you to a repo. And let's go do that Java client so we can show some interactions here. So I'm going to create the client, a reactive web client that allows me to consume those values across a network boundary. So let's see. I'll just, in the interest of fairness, we're going to use a Java Maven project. We're going to change this to, and I'm going to change this because it bugs me. There we go. No, you know what? I'm not. I'm just going to leave it the same. So we'll make this, variety is the spice of life, right? I'm going to remove the Mongo stuff because this is not a service. This is our client we're going to be consuming with. So let's save that down. And once again, go out here. We'll unzip this. And we'll open this. Boom. The first thing I want to do is go to my application.properties and put in a server port so I don't have a port conflict. Those are always fun. And go to our main application class, and let's define our domain again, this time in Java. So we've got a coffee class, coffee, right? Private string ID and name, pretty simple. Oh, you know what I should do? Just in the interest of time and speed, I'm going to go back and just use Lombok. So there. So dependency, Lombok. Come on. There we go. Look at that. Happy, happy. OK, so now we can get down to business. App. So let's go and break this down. So I'm going to make this, annotate this at data, at norgs constructor, at require, or excuse me, actually all args constructor in this case. And that gets us what we need for that. We also, again, want our coffee order class, private string coffee ID, private instant, yes, there we go. Come on. Import class when ordered. So at data, at norgs constructor, at all args constructor. OK, good enough. So that gets us started there. Oh boy, I keep wanting to hit that. New Mac. OK, so what I want to do at this point is just create our demo. Let's see. Let's create our web client bean. So I'm going to create my web client. Web client. Whew, you can tell I'm used to typing Kotlin now. So return web client dot create, and I'm going to point this to my backing service, localhost 8080/coffees. That's kind of our base URI, right? And then I'm going to, actually that is create. I can just go straight there and shortcut it. So that's good. Now let's create our component here. Component class demo. And we want to auto-wire in our web client. So we inject that via our constructor, and let's get this party started. So we'll do a post construct method, private void, run. Let's run. So let's do a client.get. We don't need to specify any additional URI because we've got the base URI with coffees, and that's sufficient to get us started. So we'll just retrieve that, and then we'll convert that body to a Flux, in this case of coffees, right? Coffee.class. And then let's filter that. So we take our coffee, and what we want to do is do a coffee.getName equals ignore case of, let's see, what do we have here? There we go. So let's grab one of our coffee names. Oh, Bourbon Jungle. That's got to happen. OK, so let's go over here. There we are. Scroll that up just a bit and close that out. So there we go. We've got Bourbon Jungle. Yes. OK, perfect. And then let's flat map that. And we'll take that coffee, and we'll do another client call using that. We'll do a get, and we'll add to that URI and add ID/orders so we can get the orders for that particular coffee, the Bourbon Jungle, right? And we'll retrieve that. We'll create or convert that body to a Flux, in this case of coffee orders, right? And again, nothing happens until we subscribe. So let's subscribe to the whole mess right here. And then we'll just do a system.out print line so we can see what's going on. And we'll tidy that a little bit, and you can kind of see the structure of it. Let's run it. And we're exactly 1 minute over, which is like almost on time, right? So, and again, we've got some issue. Oh, kind of important to indicate what we're expecting for an ID here. So coffee dot get ID. So let's try that again. All right, so let's blow this up, because this is going to work. Things always work in demos. Look at that. OK, so it works. It works. OK. Sorry. I guess I was way more excited about that than you were, but that's OK. All right, so let's go back here, and we'll wrap up strong, and then we'll go grab some coffee and snackage, right? So, oh, that didn't happen. Whew. Momentary brief hiccups. But here's some additional resources that you might appreciate. The Reactive Streams initiative is well documented, the kind of the impetus behind it, as well as the textual specification, the API, the ins and outs of it. Project Reactor, we actually have really good documentation out there. If you're interested in how to debug, how to trace, things like that, stuff that you'll never need to use, right? But it's very well documented. I'm kind of happy and proud of that. So please check it out. It's a very nice site, and if you have any additional questions, by all means, do reach out. We're on Gitter, and I'm on, like I said, I live on Twitter. And of course, the repos that actually the code that I showed, and much, much more in both the service and the client, the service and the consumer in Java and Kotlin are both out there under this meta repo for FSR, full stack reactive, right? And I didn't get to any of the rest of the stack, but it's, as we say, a good start. So thanks for coming. Please stay in touch, and thanks for coming, JFocus.